All right. Take two. So, hello again, Max. This
How you
is
doing, Tom?
color deficiency. We finally got round to it. No one thought it would happen. It's
It's a
happening.
long time coming, this one.
This isn't on purpose, but I've got like all this color behind me. Obviously, certain viewers might not be able to see, but
Right, let's have a look. I'll start sharing my screen now for everyone, Tom, okay?
all right then. You said that and then your face lit up. It looked like you were just sharing your screen with yourself. Also, you've muted yourself, I think.
Sorry, how's that? Right, lovely. Can you see my screen all okay?
Yeah, beautiful. Yeah.
Perfect. Right, okay. So as Tom says, we're going to just be talking colour deficiency today. We're going to go over just the different types of colour deficiency and why they occur. There'll be a little bit extra of the anatomy stuff that we discussed a couple of weeks ago. I've got a little bit of a bit of extra on that links to the colour deficiency at the start, which you guys might find interesting. But the same rules apply. If there's anything I haven't touched on that people want me to, just ask in the comments, and me and Tom can go into that as soon as for you. Okay, so in terms of colour deficiency, the best way to start it would be talking about trichromacy itself. And the best way to describe trichromacy is essentially just a person who has normal colour vision, so no real issues with their colour vision at all, and they'll be seeing just about any colour that you need to. I've got the example of the Skittles here, which I thought was quite a nice way to show you all.
It's definitely a colourful picture.
That's it, yeah. But it's the best way to sort of start by talking about it, just to show you what someone who hasn't got a colour deficiency would be described as.
Yeah,
okay.
yeah.
Now, the last meeting we talked about the retina and briefly touched upon the different types of photoreceptor cells, rods and cones. The rods being the photoreceptor cells that see in the darker conditions, and the cones that see in the lighter conditions. Okay, and that's will fall on the back layer of the retina, which you can see here. Okay. Now, what we didn't discuss last week, just because we didn't go into it in too much detail, was that there's a few different types of cone cell itself. Okay, we've got a small image here of the cone cells next to the rod cells. Okay. Now, the cone cells can be broken down into three main sort of types, if you like. Okay, we've got the short wave cones, or blue cones, and their peak sensitivity can be seen here, 420 to 440. Okay. We then got the middle wave cones, which are also known as the green cones. And you can see their peak sensitivity here is 534 to 545. And finally, we've got the long wave cones again, which is red cones. Okay, and their peak sensitivity is 564 to 580.
Could go on. Sorry.
No, go on.
I was just going to say, just for viewers' purposes, UV light actually goes up to 400, well, 420 really, but most UV light is just 400.
Bang on. Which is why we use the term UV 400 actually, yeah.
Yeah. So that, if ever you go get a pair of glasses and you see on your little slip saying like what type of lenses you've got UV 400. It's a UV filter up to the wavelength of 400. Perfect. You can actually get UV 420, but it's not unnecessary. It's just like that 20 nanometers is
Yeah, I mean, I must admit, I in the 5 years I've been doing this, I've never come across the 420. So.
Oh yeah, well, just to brag, I do 420.
there you go. But no, that's a great point there, and it's a good way to compare it actually. And what we can do once we've finished doing this, I'll send some images over to Tom so we have like the spectrum for everyone to see. Perhaps we can attach that when we post the video actually, so we'll do that once this video is done.
Certainly, yeah. Thumbnail. There's also just to add to that, infrared, which is the other end of the spectrum, 600 nanometers.
Yeah.
I would assume that again, like UV, that goes down to 580.
Yeah.
But I think the reason most is 400 and 600, it's because like some people, what's it called, tetrachromacy.
That's it. Yeah.
Yeah, I think people like that can actually see those extra nanometers.
Yeah, see, that's something I need to read up on personally for later meetings.
Yeah, I'm only
No,
theorizing
no,
myself, to be honest.
I see. I can definitely see the theory behind that. And in
um,
terms of we talk about red as well, there's certain sunglasses tints and types that can help with stuff like that as well. And we'll definitely, I mean, me and you, we intend on doing a sunglasses talk in the very near future. So I'll definitely make sure we touch upon that in the next week
yeah,
or so, for you guys.
I mean,
Sure.
to be fair, as you state on here, it's peak sensitivity anyway.
Yeah,
So like, you
yeah.
know, there's green that is lower than that and higher than that.
Absolutely, and what you'll find is wherever you go, you will probably see ever so slightly different numbers as well.
Yeah, absolutely,
One
for
has
sure. I
slightly
mean,
different results. So
it's
uh,
it's a bit
this,
difficult to measure a nanometer in it. So
exactly, yeah, no,
you know,
exactly right.
um,
So they're the three types of cone cell, and as I said, we've got a rod cell here just to compare it. Moving on to that. So the first type of deficiency we're going to talk about is anomalous trichromacy. And what this means is where all three of the cones itself, so the three cones here, they're all present within the eye, but one of the cones isn't effective as it should be. So it's not working as hard as the others and not working as hard as it should be. Okay, and there are three types of this anomalous trichromacy. So you've got trianomaly, which is where the blue cone isn't working sufficiently. You've got a deuteranomaly, which I had to rehearse saying before we started, and that's where the green cone isn't working properly. And finally, protanomaly, and this is where the red isn't working properly. So that's that first type of deficiency. Go on, Tom. Sorry.
I'm just like sort of theorizing, but I'm guessing the cone for red light is the first cone, green is second, blue is third, and
Yeah.
the reason because pro would to me suggest primal first.
Right.
French for two is deux, so
Yeah.
I'm
Okay.
guessing
Yeah.
that's
Yeah.
where
Yeah.
that comes from.
Yeah.
And
And then
then
you've got try.
you know, try.
As well. Yeah.
Uh,
I've never thought of it that way before, and I
yeah.
won't say yes because I don't want to promise.
Yeah, no,
I mean,
sorry,
the
I'm
logic,
just
the logic is
yeah.
definitely there. But
No,
no,
tonight you've caught me after a beer, so I'm a little I'm a little
no,
extra excited, I guess.
no, that's good. No, no, I'm sure that the logic is definitely there, but I won't confirm
Yeah.
nor deny it. So the next one we're going to talk about in terms of deficiency itself is just called dichromacy. Okay,
Yeah.
and this is where one of the cone types is either not present at all in the eye, or it is present and it's not working at all. So if we compare that to anomalous trichromacy, the cone type was there and it was working, but
Right.
just not as well as it should have done. Whereas with dichromacy here, it's not working at all, or it's actually not even there. Okay. Now, again, there are three types of that, and you've got tritanopia, which is with the blue cones, and this is really, really rare. I think it's something like 1 in a million. It's a really, really rare type of color deficiency. We've got deuteranopia, which is the green cones, and protanopia, which is the red cones. And you probably see there's a bit of a pattern forming with the actual names here with the tri, do, and pro, as we had with the first type of deficiency there. Okay.
In terms of very rare, I'm guessing you know, like especially rare in what is it? Like one gender is more prone to color blindness than the other, isn't it?
Exactly right, and I'm really pleased you mentioned that actually, because that was the next slide we've got here. So roughly around, again, this is rough numbers, roughly around 8% of men will struggle with color deficiency in comparison to the small number of women, which is only 0.2, which is only 0.25%. Okay, the reason for this, or the main reason for this, is due to the most common type of inherited color blindness falls on the X chromosome. Okay, and as you can see, women have 2 X chromosomes. So if you've got the actual gene for the color blindness on this first X, most of the time it will be cancelled out by the fact that you've got a second X here. Okay, whereas with the men, if there's the gene for color blindness on this first X, we haven't got an X here that can cancel that out. So we're far more likely to see men with color blindness than we are with women.
And that actually answers the question I was going to come to afterwards. Is it hereditary? Like, I guess.
So what you'll find is
certain ones.
Sorry, Tom. I'm just thought it'd be quite good to show a diagram here for. I was looking at this the other day, and I found a really, really good diagram for it.
Oh, being a Tolkien fan, I love a good tree.
So you got here people that are coloured effective be fully coloured in. A carrier is half, and normal vision is just the clear. And you can see how it passes through. I mean, if you're watching the video, I won't explain the whole thing, but you can pause the video and look into this properly. But you can see if we've got 2 people that are coloured effective, the chances are they're going to have a coloured effective offspring. Whereas if you're mixing it, there's a different chances of it happening. So if you are actually watching it, feel free to pause and have a look. There's another quite a good image there for it as well. So feel free to pause the video and look through these images in more detail if you like. But I found these particular images quite useful when reading up on this topic itself. I quite liked those ones. But
that second one, sorry, that was clearly someone thought it would be quite funny to put a color blindness chart in green and red, the most common types of color blindness. I'm assuming.
I didn't think about that, but yeah, you know. But no, I'm glad you brought that one up, Tom, because that was something that's quite commonly asked. You'll definitely see more men struggling with color blindness than women, and that is the main reason for it, is the genes there. Okay. So another type of deficiency is known as monochromacy. And when you get people coming in talking about color blindness, most people tend to think this is what it is, and this is the only thing color blindness is. And that's when someone sees in black and white, essentially. If you talk to someone and ask them what they think color blindness is, most of the time they're going to just say that you don't see color at all. And that they just see life like a black and white film. And that isn't the case for most people. However, it is the case for some people. So I attached a diagram here. So you can see this is what someone without a deficiency would see. Someone who is suffering from monochromacy would see this way. Okay, so this is what people tend to think of when you say color blindness. But this is pretty rare. I don't have a stat label to it, unfortunately, but I can find one out for you. But this is. No, go on, Tom, sorry.
Because I looked into color blindness a little bit as well. Like when I was asking if we could do a talk about it, and I think quite a lot of the time this might be due to trauma to the brain. Not necessarily all the time, but I think most of the time it's trauma to a certain part of the brain.
It's something I think I've seen that somewhere as well, and I haven't actually looked up the exact reasons for monochromacy occurring, but again, it's definitely something that I'm happy to do, even just write up a little bit on, and you can post it below the video if you like, Tom. That's not a problem.
Yeah, sure.
But no, this is the main thing people think of when you say color deficiency. This is what they think it's like, but as you can see, this tends to be more like what we're looking at here. But it's quite an interesting one, that one there, because it's quite rare in comparison to the rest of the deficiencies that we discussed already today. Right. Oh, so the types of monochromacy itself, we've got rods monochromacy, and this is where a person can only see using the rods, therefore they can't see in any color or detail itself. And we looked at the rods and cones last week, and we've discussed it a little bit today as well. So these cones themselves aren't working at all, and they're only seeing with their rods, okay, which see in black and white, essentially in dull conditions. So any real color or detail, then they would really struggle with, unfortunately. Okay. And the other type of monochromacy is blue cone monochromacy, and that's where only the rods and the blue cones are actually working in conjunction with one another. And again, this is really rare, and this is also around 1 in a million. So we don't really see much of this at all, and it's a bit of a strange phenomenon on that.
Oh,
I should try and find an image of what life would be like for this kind of person, but there wasn't really even anything image-wise that I could show you, unfortunately.
yeah, no, that sounds
Which
like a
is shame.
difficult one to.
But it's an interesting one, and it's pretty rare. So therefore, they don't really have much examples of it, I'm afraid. But if I come across anything in the coming weeks, I'll make sure that it's posted for you guys. No problem at all.
I always think it's a bit difficult to actually confirm whether or not a picture is what someone colorblind would see,
Yeah,
because you show them a picture that to us looks like the image from a colorblind perspective, and say, is that in full color? Well, yeah, it is, but they might have actually they might not be seeing the same color as us, sort of thing. You know what I mean? Like, I might be colorblind and no clue.
Exactly, and it affects people in so many different ways. As I said, this is what most people think it is, but we've already gone over the fact that it affects people in so many different ways that it's very hard to pick up on. And actually, we'll be moving on to that in just a second, talking about how we can pick up on these things in practice. So we'll move on from monochromacy onto the testing for color deficiency itself. Now, we're only going to discuss one way of testing for color deficiency, but it's probably one of the more common types, the ones that you'll see in practice more often than not. Okay, and this is known as the Ishihara color test, and it's like a booklet of color plates which measures a person's ability to be able to tell the difference between colors. Okay, as you can see here, well, hopefully if you haven't got color deficiency, you'll be able to see here. You've got a blue background here, for example, bluey green background with reddy orange numbers in the middle. So what we'd do is you'd sit a patient down and ask them what the number is in the circle. If they can't tell you what the numbers are, we can do like a maze type thing, so they can follow a maze through the circle itself as well. So it's not just for adults, we could do this on children with following a maze technique as well. Okay. Now, the Ishihara color test itself consists of 24 plates, and we'd consider someone to fail this test if they got 4 wrong answers. Okay. They get 5 seconds per plate, and unfortunately, this test can't actually find issues with the blue cones, which is one of the downsides to this test. And I must admit, it's not something I knew about before we started researching this topic. So that's an interesting one.
I didn't know I didn't know about the 5 seconds allocated per plate. Actually,
Yeah,
I thought you just had as long as you like to.
No, no, you get 5 seconds for it. Some of the plates as well, it's worth bearing in mind, won't have any pattern or number on them at all. They're like placebo plates, if you like. So what you'll find is they are just a mixture of colors in a circle, and it's there just to make sure people aren't guessing.
Yeah, I know. Especially with kids thinking like it's cool to be color deficient, like they're. They tend, I heard an optometrist say it once before. You sometimes have to double guess them and double guess yourself because they just try and be color deficient.
Yeah, big time.
Not really helping anyone, is it?
Parents saying, "Oh, I think my child failed their sight test on purpose," but there's ways of catching them out, so no one ever has to worry about that.
Yeah.
But no, that's really everything we've got on color deficiency today. We just sort of touched on all the different types of color deficiency. Done a little bit more information on the anatomy, what we slowly touched on last week, and how we can spot this in practice as well. So if there's any questions about that at all, we'd love to hear them, and I'll be more than happy to answer them as soon as I get them from you guys.
Just quickly, if anyone's sort of thinking about like where Ishihara comes from, I'll admit I've Googled it.
Oh
I'm
my God.
googling it right now. Shinobu Ishihara is the founder of this, or the creator of this test. He was a Japanese optometrist, and apparently an army surgeon.
Oh, right, okay. When did he come up
Living
with this one then, Tom?
uh, I can tell you it was definitely between 1879 and 1963.
Right, okay.
1918. There we go.
Oh, okay.
So he's obviously a man that, even though the world was in and out of war around this time, he was thinking, you know what the world needs? Bit of colour.
There you go. And there he is. I've
Yeah.
got him on screen.
There we go. Yeah.
Perfect.
So
Brilliant.
there we go.
Well,
For
thanks for
someone
that,
so
Tom.
interested in colour deficiency, he wore white suits. Yeah. All right. Well, thanks for that anyway, Max. And
No, not a problem. Not a problem. So as I say, same rules apply. Any questions at all, just send them straight over and I'll get a response back as soon as possible.
yeah.
And also, obviously, we are going to carry on doing this stuff. So if you want to see any videos in particular, we're always open to ideas. So just send a few ideas over and we'll try and keep everyone as happy as possible, of course.
Yeah. If you have a certain sort of color deficiency, then maybe leave
Yeah,
it in
let us know.
comments
Yeah.
and such, and maybe we can even go more in depth about
Yeah,
certain
yeah, we'd
people's
love to.
color deficiencies. Yeah.
Yeah, would love to. Sounds good.
Yeah.
Perfect. But yeah, no, in terms of future videos as well, let us know what you want to see, and we'll do our best to accommodate it, of course.
All right. Cool. Then yeah. Ciao from me.
Brilliant. Cheers, Tom. Thanks, everyone.